Hey everyone, welcome back. Today we're going to be doing a deep dive into something that I think is super important and pretty fascinating, and that is large language model security. And we're going to be looking at that through the lens of a really, really cool document that was written by Rich Harang over at NVIDIA.
And I think what makes this document so interesting is this isn't just somebody who's like read a few things about LLMs and then decided to write about it. This is somebody who has been involved in this world for over 14 years. I mean, he was building, breaking, and fixing ML security systems for all sorts of places like the US Army and Sophos and Duo Security. Like, this is a guy who has been in the trenches and he's been working with LLMs since almost the very beginning. So I think he has some really unique insights into a lot of the security challenges that these models pose.
Yeah, I mean, I think that that background is super important. And, before we kind of get into all the nitty-gritty details of LLM security,
Yeah.
I think we should all get on the same page about how these things actually work.
Yeah.
I get that they can like generate text and hold conversations, but what's actually going on like under the hood?
So at a very basic level, you can think of LLMs as just being these like incredibly sophisticated pattern matchers. They are trying to predict the probability of the next word, or even like the next part of a word, appearing based on the text that came before it. So it's almost like having like autocomplete, but instead of suggesting, one or two words, it's like generating whole paragraphs. It's generating entire
So
conversations.
it's kind of like they're making these educated guesses about what comes next
Yeah.
based on just massive amounts of data
Yeah.
that they've been trained on. I mean, that's impressive, but I can already see like how this could go wrong. Like
Yeah.
what happens if it makes the wrong guess early on? It can that kind of like cascade into bigger problems further down the line.
Yeah, you're absolutely right. And that is one of the inherent risks with LLMs is this lack of like true understanding. They can get locked into these chains of statistically likely but ultimately incorrect outputs. It's almost like playing that game of telephone, where like one little misinterpretation at the beginning can completely change the message by the end.
And to make matters worse, I'm guessing they don't really have a clear separation between what's like input and what's output.
Exactly. It's all just one continuous stream of data to them. And that makes them incredibly vulnerable to manipulation because anybody who can feed input, whether it's intentionally malicious or not, can potentially influence the output. And because these models aren't actually reasoning about what they're processing, they can be easily tricked into generating harmful or misleading content.
So even if the LLM itself is like secure the output that it generates,
Yeah.
could be manipulated or used in ways that it wasn't intended for, that sounds like a security headache waiting to happen.
Yeah, it really is. And it brings us to another vulnerability, which is this idea of prompt injection. And so you can kind of think about this as tricking the LLM into executing commands that it wasn't supposed to. So somebody could craft like a seemingly innocuous prompt, but it contains these hidden instructions. And that can hijack the LLM's output and potentially like leak sensitive information or even gain control of the system it's running on.
Okay, that's starting to sound a little scary now. It's kind of like those phishing scams where like one wrong click can compromise your whole system. But instead of clicking a link, we're talking about carefully worded prompts that can kind of exploit the LLM's weaknesses.
Yeah, that's a really good analogy, and it highlights why Harang really emphasizes the importance of placing LLMs within these secure boundaries. So it's almost like putting a fence around a really powerful but unpredictable machine. You want to be able to leverage its capabilities,
Yeah.
but also control its potential for harm.
That makes a lot of sense. So we got these inherent risks that come from just the nature of how LLMs work. But I imagine things get even more complicated when we start integrating these things into larger systems.
Oh, absolutely. And while attacks on the LLM itself are definitely a concern, I think the real danger emerges when they're connected to other tools like databases and external sources of information, because this kind of interconnectedness creates this much wider attack surface that exposes the entire system to a whole new set of vulnerabilities.
Yeah. And this is where I think things get really interesting and also like kind of unnerving.
Yeah.
Because it's like opening this Pandora's box of potential security risks. So can you give us like a specific example of how these interconnected systems can create vulnerabilities?
Yeah. So one common but also very risky approach is this thing called retrieval augmented generation, or RAG.
Hmm.
And it allows LLMs to access external data like company documents or even information from the web. So it can provide like more comprehensive and contextually relevant responses. But this connectivity also introduces a whole bunch of new security concerns.
So it's kind of like by giving the LLM access to more information, we're also potentially exposing it to all the vulnerabilities
Hmm.
that already exist in those external systems. So it's like the classic case of more is not always better.
You got it. And Harang actually shares some really compelling case studies from his own experience that illustrate just how serious these vulnerabilities can be.
Okay, so let's hear about those case studies then. Like, what kind of real world breaches has he encountered? Wow, those case studies are really something else. They really
Yeah.
like paint a picture of what can go wrong when these LLMs are integrated into these larger systems, like improper document permissions and insecure logging and targeted RAG poisoning. It's a lot to keep track of.
Yeah, it really is, and that's why I think it's so important to like really understand these real world examples, because it's not just about, theoretical vulnerabilities, it's about seeing how these exploits can actually play out and the kind of damage that they can cause.
And speaking of damage, one of the things that really stuck out to me was this concept of targeted RAG poisoning. Can you unpack that a little bit more for us? Because it sounds pretty sinister.
Yeah, so it's basically all about attackers manipulating the external data sources that an LLM relies on through RGA. So they might inject malicious content, they might subtly alter existing information, or even introduce biases that can skew the LLM's responses.
So it's not about like attacking the LLM directly. It's more like poisoning the well that it draws information from. That's pretty devious. I can see how that would be incredibly difficult to detect.
Especially if the malicious content is like cleverly disguised.
Yeah, exactly. And it really highlights why security professionals need to start adopting this more holistic approach to LLM security. We can't just focus on securing the model itself. We need to be looking at the entire data pipeline, from the sources that it's pulling information from to the way that information is processed and ultimately delivered to the user. Yeah, it's like building a secure fortress. You can't just focus on reinforcing the walls. You got to think about the water supply, the food stores, even the messengers coming in and out. Any weakness in that chain can compromise the whole system.
Exactly. That's a great way to put it. And it kind of leads us to another really important point that Harang makes in the document, which is the need to really understand data flow within these LLM-enabled systems.
Data flow, so you mean like mapping out where the data is coming from, where it's going, and how it's transformed along the way.
Yeah, exactly. Because by tracing these data pathways, we can identify potential points of leakage or compromise. We can see, where sensitive information might be inadvertently exposed, whether it's through insecure logging practices or overprivileged plugins, or even things like, guardrail refusals or response caching.
Wait, hold on a second. You mentioned guardrail refusals and response caching earlier, but I'm not sure if everyone's familiar with those terms. Can you just kind of explain what those are and why they pose security risks?
Sure. So guardrail refusals are instances where the LLM refuses to answer a question or perform a task because it violates some predefined rule or policy. And these rules are meant to keep the LLM from, going off the rails and generating harmful or inappropriate content. But the problem is that these refusals themselves can sometimes leak information. So, for example, an attacker could use a series of carefully crafted prompts to kind of figure out what those guardrails are, effectively mapping out the boundaries of what the LLM is allowed to do.
So it's almost like trying to figure out the combination to a safe by like listening carefully to the clicks as you turn the dial.
Yeah, exactly. And then you have response caching, which is a technique that's used to improve efficiency. So the LLM will store previous responses and then reuse them when it encounters similar prompts. And this can save time and resources, but it can also inadvertently leak information if it's not implemented carefully.
I see. So if the LLM is caching sensitive information and then reusing it in response to like a different prompt, that information could potentially be exposed to somebody who shouldn't have access to it.
Exactly. It's a subtle but important point that a lot of developers might overlook. And it brings us back to that importance of data flow analysis. By carefully mapping out how data is moving through the system, we can identify these potential vulnerabilities and then take steps to mitigate them.
All right, so data flow analysis is key. What else does Harang recommend?
Well, once we have a good understanding of data flow, then we can start applying another really fundamental security principle, which is the principle of least privilege.
Oh yeah, the classic idea of like granting users and systems only the bare minimum access that they need to do their job. It seems like a pretty straightforward concept, but I'm guessing applying it to LLMs is a little bit more nuanced.
Yeah, you're right, because in the context of LLMs, least privilege extends beyond just user access. It also applies to the LLM itself and the plugins that it interacts with. So we need to carefully restrict the information that the LLM has access to and limit its capabilities to only those that are absolutely necessary for the intended use case.
So it's kind of about compartmentalizing information and functionality to reduce the potential damage if one part of the system is compromised. It's like that old saying, don't put all your eggs in one basket.
Exactly. And this is especially important when you're dealing with plugins because plugins can, extend the LLM's capabilities, but they can also potentially expand its attack surface. So we need to be really scrutinizing every plugin, making sure that it only has the necessary permissions and access to minimize the risk of, unintended consequences.
Speaking of plugins, those seem like a bit of a double-edged sword. I mean, they offer a lot of power and flexibility, but they also seem to introduce their own set of vulnerabilities. Didn't Harang mention some specific examples of how plugins can go wrong?
He did. He actually talked about some cases involving older versions of LangChain, which is a popular framework for building LLM applications. And in one instance, there was a vulnerability that could allow an attacker to manipulate database queries and potentially gain access to sensitive information. And in another case, a vulnerability could have tricked the LLM into making requests to unintended servers, which could expose internal systems or data.
Wow, so these aren't just like hypothetical risks. These are real-world exploits that have been documented
Yeah.
and could have had serious consequences.
Yeah, and it really underscores the importance of carefully vetting and securing any plugins or third-party components
Yep.
that are integrated into these LLM-based systems. We need to treat them with the same level of scrutiny that we would any other critical piece of software, because a vulnerability in a plugin can ultimately compromise the whole system.
Okay, so we've covered a lot of ground here. Data flow analysis, least privilege the dangers of plugins. It's clear that securing LLM applications is like a really complex undertaking. But it seems like Harang is advocating for this like proactive, almost paranoid approach to security.
Yeah, he is, and for good reason. With technologies as powerful and unpredictable as LLMs, I think we can't afford to be complacent. He emphasizes the need to assume that LLM output is potentially attacker controllable, and to design downstream components as if they were internet-facing, meaning they could be targeted by anyone.
So it's about adopting this kind of trust no one, verify everything mentality when it comes to LLM security.
Exactly. It's about building in multiple layers of defense, anticipating potential attacks, and constantly monitoring for any signs of suspicious activity.
That sounds like a lot of work. But I guess it's the price we pay for harnessing the power of these incredible technologies.
It is, but remember, security doesn't have to be like this all or nothing proposition. There are practical steps we can take to mitigate these risks and build more secure LLM applications.
And speaking of practical steps, I'm eager to hear more about what else Harang has to say. Like, what specific advice does he offer for actually hardening our LLM applications and protecting ourselves from these potential threats?
Okay, so we've talked a lot about the potential problems here, but now I want to know, what can we actually do about it? It's starting to feel like there are LLM security landmines everywhere.
I get that feeling. But the good news is that Harang doesn't just tell us all the stuff that can go wrong. He actually gives us solutions. And a lot of his advice really comes down to just applying like well-established security principles to this new LLM world.
Okay, well, that's at least a little bit reassuring. So what's the first step then in making our LLM applications more secure?
One of the things he really stresses is treating all LLM output as untrusted. And we've kind of been talking about that a little bit throughout this whole deep dive. But it means we can't just blindly accept whatever the LLM spits out as like the gospel truth. We always have to validate it. So basically, don't take the LLM's word for it. Double check, especially if you're going to be making important decisions based on that output.
Exactly. And that same principle applies to how we design and interact with plugins. Harang says we should be hardening those plugins as if they were internet-facing services. So we have to assume that they could be targeted by attackers and build in some really robust security measures.
Which makes sense because plugins are often that like bridge between the LLM and the outside world. They're handling things like API calls and data retrieval and sometimes even code execution. We definitely don't want any security holes there.
Absolutely not. And his next piece of advice kind of builds on this idea of vigilance when it comes to data leaks. We've already talked about a lot of the potential sources of those leaks, but it's worth repeating, like, we need to be really careful about our logging practices, especially for any services that are accessed by plugins. And we need to really scrutinize those plugins for like excessive permissions or the ability to make arbitrary requests. And don't forget about those vulnerabilities that can pop up with guardrail refusals and response caching.
You know, it seems like to really nail LLM security, you almost have to have a different mindset. It's not just about putting up a few technical safeguards. It's about constantly thinking like an attacker, looking for those subtle weaknesses that could be exploited.
Yeah, you're absolutely right that constant vigilance is so important. And it ties into his next recommendation, which is about isolating sensitive data from the LLM as much as possible.
Right. So we've talked about that. Don't give the LMM access to anything that it doesn't absolutely need to know. Treat it kind of like a vault. Only the essential information gets in there.
Exactly. And this applies not only to the data itself, but also to how we handle prompts and responses. Harang says we should treat both of those as private by default and minimize logging whenever we can. Because remember, those prompts often contain sensitive information. And even seemingly harmless responses could reveal patterns or insights that we don't want to fall into the wrong hands.
So it's all about minimizing the data footprint, both within the LLM and in those surrounding systems. Less data exposed means less opportunity for leaks or manipulation. It's kind of like applying the principles of minimalism to security.
I like that analogy. And I think it highlights one of the key takeaways from this entire deep dive. Security has to be baked into the design of LLM applications right from the very start. We can't just tack it on as an afterthought. We need to be thinking about these risks at every stage of the development process, from the initial design choices to how we handle data, to how we manage plugins, and even how we interact with the LLM itself.
It's a lot to think about, but this deep dive has been so insightful. I'm walking away with a much better understanding of just how complex LLM security is, and even more importantly, what we can actually do to address those risks.
I agree, and it's definitely a field that's changing rapidly. There's still so much to learn, but if we can adopt that proactive and informed approach to security, we can harness the power of these incredible technologies while still minimizing the potential downsides.
Well, that wraps up our deep dive into LLM security for today. Listeners, I hope you found this conversation as informative and interesting as we have. These LLMs are really revolutionizing so many parts of our lives. But just like with any powerful tool, we need to use them carefully and with a deep understanding of both their capabilities and their limitations. Be sure to check out the show notes for links to Rich Harang's full document and other resources we talked about today. And until next time, stay curious, stay informed, and stay secure.